Hello, this is Dr. Muhammad Hassan Joker. In this video, I want to talk about the use of artificial intelligence in medicine with an emphasis on rheumatology. How familiar are you with the following words and terms? Artificial intelligence, machine learning, deep learning, and artificial neural networks. I will explain these words to you. I will first briefly talk about artificial intelligence. The first question is, what exactly is artificial intelligence? Artificial intelligence, or AI, is the science and engineering of making intelligent machines. So, these machines must be able to think like humans, act like humans, think rationally, and act rationally. So these machines must be able to perceive, gain experience, learn, reason, and solve problems. There are two types of AI. The first type is weak AI or narrow AI. In this type of artificial intelligence, the machine is trained to perform tasks in a certain area, such as driving or playing chess. These machines work well in this particular area. For example, the machine can compete with the best chess players, but can do nothing else. The second type is a strong AI or general AI. In this type, the machine must be able to function as a human in various fields. We still have a long way to go to achieve this kind of artificial intelligence. In the future, it is possible to build a kind of machine whose intelligence is superior to human intelligence, which is called superhuman. In this figure, you can see the subfields of artificial intelligence. The most important subfield is ML or machine learning. Machine learning itself has three types: supervised learning, unsupervised learning, and reinforcement learning. The rest of the subfields of AI are natural language processing or NLP, expert systems, machine vision, machine speech, planning, and robotics. In the next slide, I will talk a little about the history of artificial intelligence. The term machine learning was first used in 1952. Artificial intelligence was first described in 1956. The term deep learning was created in 2000. In 2010, gastrointestinal endoscopy was performed with the help of artificial intelligence. In 2014, Amazon's virtual assistant Alexa is released. And in 2017, FDA approved the first deep learning application in healthcare arteries. As I said, machine learning is the most important branch of artificial intelligence. A machine that learns by itself. Machine learning is a computer program that has the ability to automatically learn and improve from its experience without human intervention. Machine learning applications are based on neural network algorithms. To produce a machine learning system, the machine learning specialist first gathers the data needed to train the machine and then designs a number of algorithms. Then he or she makes models for the system. The input data is then fed to the machine. The machine makes a prediction with this data and using algorithms. This prediction is checked by the machine learning specialist. If the prediction is incorrect, the necessary corrections are made to the algorithms. And this is repeated until the machine works to an acceptable level of accuracy. When the performance of the system reaches an acceptable level, the machine is ready to work. I said that machine learning applications are based on neural network algorithms. What is an algorithm? Algorithms are set of step-by-step instructions for the computer to follow. They are at the heart of all computer programs. An algorithm is a set of instructions that describes how to get something done. Artificial neural networks are made by mimicking the human neural network. Nerve cells or neurons have a cell body, a number of dendrites, and a cell appendage called an axon. The message is transmitted from the previous cell to the next cell through dendrites and then to the next cell via the axon. There are a large number of neural connections or synapses in the nervous system, and the complex function of human brain is largely due to these synapses. In an artificial neural network, there is an input layer, one or more hidden layers, and an output layer. Each layer is connected to its before and after layer. What is deep learning? If an artificial neural network has more than one hidden layer, it is called a deep neural network. Systems that use deep neural networks are called deep learning. Machine learning models that aren't deep learning are based on artificial neural networks with just one hidden layer. So far, you have learned that deep learning is a subfield of machine learning, and machine learning is a subfield of artificial intelligence. Deep learning models are based on deep neural networks. Deep neural networks have multiple hidden layers. Each layer further refines the conclusions of the previous layer. This movement of calculations through the hidden layer to the output layer is called forward propagation. Another process called back propagation identifies errors in calculations, assigns them weights, and pushes them back to the previous layer to refine or train the model. Let's continue with an example. We want to build a machine that recognizes the image of a dog. We need to design an artificial neural network with several hidden layers. How a machine recognizes an image? The method of image recognition by a machine is completely different from that of humans. The machine first breaks the image into pixels. It then detects the value of the pixels. The next layer identifies different edges of the image. In the next layer, it combines the different edges of the image and identifies the features, and then combines the features together, and finally it can say whether an image is related to a dog or not. The same is true for radiological images. For example, a mammography image. The machine first breaks the image into pixels. It then detects the values of the pixels. The next layer identifies different edges of the image. In the next layer, it combines the edges and identifies the features, and then combines the features together, and finally it can say that there is a malignant or benign mass in the mammography image. As I said, machine learning has three types: supervised learning, unsupervised learning, and reinforcement learning. In supervised machine learning, to train the machine, we first give it some labeled data. For example, we give the machine some pictures and say that these are apples. After adequate training of the system, we give it a picture and want the machine to say whether it is an apple or not. The next type of machine learning is unsupervised learning. Unsupervised learning is used for clustering. In this type of machine learning, we give unlabeled data to the system. We don't tell what each data point is, and allow to find some structures in the data by the algorithm. The system places these data in different clusters due to the similarities. For example, we give some pictures of fruits to the system, but we do not say what fruits these pictures are related to. The system puts fruits in different clusters due to the similarities. In reinforcement learning, a software agent learns without the interference of humans by interacting with its environment. We don't tell how to perform a task, but the software agent works through the problem by itself. There is a method of reward and punishment to train the algorithm. The agent receives rewards for performing correctly and punishments for performing incorrectly. The agent practices to make decisions to maximize its reward and minimize its penalty. For example, we want to build a machine that can recognize the image of an apple. After the initial training, we give an image to the device. If it correctly detected whether this is an apple or not, we give a positive score to the device, and if it detected incorrectly, we give a negative score to it, and continue to do so until the performance of the system reaches an acceptable level. The application of different types of machine learning is different. For example, supervised machine learning is used for classification and regression. Unsupervised learning is used for clustering, and reinforcement learning is used in robots and computer games. Well, the first part of the discussion, which was related to the introduction of artificial intelligence, is over. And in the continuation of the discussion, I will talk about the use of artificial intelligence in rheumatology. Artificial intelligence has different applications in medicine. It can be used in training, in research, keeping well, early detection, diagnosis, decision making, treatment, and end-of-life care. In this figure, you can see the number of studies that have been done in the field of machine learning in medicine since 1999. As you can see, by 2009, very few studies have been conducted. And since that year, the number of studies has been increased, so that in 2019, the number has reached nearly 800. In this figure, you can see the number of studies that have been done in the field of machine learning in rheumatology. As you can see, the first study was done in 2005, and the number of studies has been increased to about 50 in 2019. This figure compares the number of machine learning studies in some medical fields. The number of studies in radiology is 2526. In ophthalmology is 304. In dermatology is 135. And in rheumatology is 109. What are the uses of artificial intelligence in rheumatology? I will discuss some of the applications of artificial intelligence in rheumatology. Artificial intelligence can be used to predict the development of a disease. For example, in a study, with the help of machine learning and the use of genes, researchers could determine the risk of developing psoriatic arthritis in patients with psoriasis. Machine learning can be used to classify diseases. For example, in a study, machine learning was used to classify rheumatoid arthritis. Artificial intelligence can be used to detect diseases early. For example, in a study, artificial intelligence was used to detect rheumatoid arthritis in early stages. As I said before, artificial neural networks are used in machine learning. This artificial neural network is designed to diagnose rheumatoid arthritis. In the input layer, the results of RF, ESR, CRP, ACPA, and other variables such as hair color are given to the machine. This data is processed by the hidden layers, and in the output layer, it is determined whether the person has rheumatoid arthritis or not. We can use machine learning to diagnose diseases. This article describes how rheumatoid arthritis can be diagnosed with the help of machine learning and using hand radiograph. We want to build a machine that can diagnose rheumatoid arthritis using a hand radiograph. We can build three types of systems. The first system is a rule-based system. In this system, we define some rules for the system. For example, Rule 1. If joint space is narrowed, the probability of RA is P1. Rule 2. If there are marginal erosion, the probability of RA is P2. Now, if we give a hand radiograph to the machine, it can say that the diagnosis is RA or not. The second type is non-deep machine learning system. There is only one hidden layer in this type of ML. For the machine, we define the radiographic characteristics of the disease. For example, joint space narrowing, erosion, and etc. and determine the weight of each variable. The third type is deep machine learning, which has several hidden layers. In the hidden layers, the machine extracts the features and learns their weight automatically. Finally, in the output layer, it can say that the hand radiograph is of a RA patient or a healthy one. Each disease may have a number of subtypes. With the help of machine learning, subgroups of a disease can be identified. For example, in one study, 3 subgroups of rheumatoid arthritis were identified using synovial tissue characteristics and RNA sequencing. Another study identified osteoarthritis phenotypes using machine learning and biomarkers. Machine learning can determine disease activity. In a study using ultrasound images of synovial tissue, disease activity was determined. In this study, images obtained from Doppler ultrasonography of the synovial tissue were used to diagnose rheumatoid arthritis. As you can see, deep artificial neural networks are used in this study. Machine learning can be used to determine the severity of a disease. In one study, neural networks were used to stage osteoarthritis using plain radiographs. We can use machine learning to predict the clinical course and prognosis of a disease. In a study, researchers used machine learning to predict chronic damage in lupus. We can also use machine learning for the prediction of clinical outcomes. In this study, with the help of machine learning and using electronic health record data, the clinical outcome of rheumatoid arthritis was assessed. In this study, deep learning models were used for scoring radiographic finger joint destruction in rheumatoid arthritis. In this study, a whole hand image processed by the model. The red rectangles indicate joints such as PIP, IP, or MCP. The numbers in yellow color indicate the joint space narrowing score, and the blue numbers indicate the erosion score. We can use machine learning to predict response to treatment. In this study, the researchers analyzed the profiling of gene expression biomarkers as a classifier of methotrexate non-response in patients with rheumatoid arthritis. And finally, machine learning can help us to predict adverse drug reactions. Artificial intelligence, like other new technologies, has its advantages and disadvantages. The most important disadvantages are occupying jobs, lack of empathy, inability to communicate emotionally, and lack of emotional intelligence. The most important benefits are high accuracy, high precision, decreased workload, increased patient face time, increased time on critical cases, saves money, and better monitoring. Thanks a lot for your attention.